Good morning, my name is Dennis. We are 14CS319 to do the fourth experiment of Bio, which is about token separation using LexType. Lex is a lexical analyzer tool, mostly used with the parse generator. It lexically analyzes or it matches the pattern given as input strings or as a file. It helps write programs whose control flow is directed by instances of regular expressions in the input stream. The Lex source is a table of regular expressions and corresponding program fragments. It has many components. YYLex. YYLex. What is YYLex? YYLex implies the main entry point for the Lex. It reads the input stream, generates tokens, returns 0 at the end of the input stream. It is called to invoke the lexer or the scanner, and each time YYLex is called, the scanner continues processing the input where it was last left off. Moving on to our program. I've given my input as int a, b, comma b, comma c, and c is equal to a plus b times 20. So as you can see here, it identifies each character, each keyword. It takes int as a keyword, a as an identifier, punctuation, comma, etc. It does the whole thing. There are a total of 14 characters here, 20 operator. Yeah, as you can see there. Now let's take a look at the program. So this is my program. The Lex program has three components. The Lex program has three components. The first being the declaration. The declaration part is right here, as you can see. We have declared the count variable as 0, initialized it to 0. Second, we have the translation rules, and that is followed by the auxiliary functions. Okay, so these three components are separated by double percentage signs. Our declaration is concluded here. We have 4 segments here: operands, which is plus, minus, slash, star, equal to, etc. Punctuation, comma, parentheses, brackets, etc. Digit we have from 0 to 9. Alpha we have from A to Z, small, capital A to Z. Punctuation is defined here. The count gets incremented every time, and print once we identify a given keyword as a punctuation, we increment the count followed by YY text. Likewise, the same follows for the operands. The count is incremented once an operand is found, and we print the following: the operator followed by a comma, and the count is incremented followed by YY text. YY text is a buffer that holds the input character that actually matches the pattern, that is the lexem, or say pointed in the string. Next we have int float. If there's any floating point, we have the count is incremented, and the YY text is also there. Likewise, we do the same thing for alpha and the digits. Then we run the main program, YYLex, and then we return 1. YYLex is again, it implies the main entry point of the Lex. It reads the input stream, it generates the tokens and returns 0 at the end of the input stream. It is called to invoke the lexer or the scanner, and each time the YYLex is called, the scanner continues processing the input from where it is last left off. And then we return 1. Then another function is called YYWrap. In that scenario, YYWrap is basically called by the Lex when input is exhausted or at the end of the file. the default wrap always returns 1, so we have return 1. So let's execute this program. lex4f.l followed by ccux.yy.c and then dot/a.out and enter our any given expression, and it will convert it down to individual words. Okay, as you can see, it categorizes every character accordingly. And yeah, that concludes our topic on Lex analysis, token separation using Lex, using the Lex tool. Yeah, our program is here, followed by the input and output. Thank you.